Alright, got a volume problem here. It says find the volume of the region bounded by y equals 4 minus x squared and y equals 2 minus x, and it's rotated around the x-axis. So the best thing to do is just go ahead and start drawing this out. It's not necessary, but it won't hurt. Let's go ahead and try and fix this. I don't know why sometimes my screen jumps. But let's see here. Okay, so the straight line, the y equals 2 minus x, is a little bit easier to draw first. So let's see. Let's kind of go out. I don't know how far out I need to go. I'm going to make an xy graph out to 4 in every direction. I know the parabola goes up to 4. But y equals 2 minus x, that has a y-intercept of 2, and it goes down 1 over 1. So let's see, it'll come across like this. Okay, that's y equals 2 minus x. And the other one here, y equals 4 minus x squared, we're up at 4, comes down 1 on each side. Then it'll come down to the x-axis. You can use something else to help you graph here, however you like. But this is the y equals 4 minus x squared. Now the things that we're going to do is we're going to rotate a region around the x-axis, and the region looks like it will be contained between these two lines. Okay. So in this case, a couple things we need to do. We need to figure out where these things intersect. We could do that by saying the two equations equal to each other, but it looks like they intersect at -1. If I plug it in, -1 into the parabola will give me 3. -1 into the line will give me 3, so that's definitely a place they intersect. They intersect at -1, 3, so over here at -1. And it looks like they intersect when x is 2, so 2 in the parabola gives me 0, 2 in the line gives me 0, so yes. When we do set this thing up, we'll have pi over the interval from -1 to 2. Okay? Because we're going around the x-axis, that will be in dx, and because there's a gap between the axis of rotation here and the inner part of the figure, it is a washer method. Okay? So if that's not apparent, it is a washer, because there will be a gap in this thing, at least in part of the places. So what do we have here? We need a big R for the outer radius. It looks like that's going to be our parabola. It's already set where it's a function of x. So 4 minus x squared, that's our outer, all the way from the line to the far end. And then our inner is the y equals 2 minus x. It's nice that both of those are y equals already. So we can just go ahead and throw those in. So we will have 4 minus x squared, and that quantity will be squared, minus 2 minus x, and that quantity will be squared. So probably the worst part of our job here is going to be some foiling and collecting like terms. So let's see here, still from -1 to 2. So we're going to square 4 minus x squared, so that'll be 16 minus 8x squared plus x to the 4th. And then we're going to subtract off 2 minus x, and we're going to square that quantity, so it'll be 4 minus 4x plus x squared. So we'll distribute the negative in the second part and collect like terms. So pi from -1 to 2. So let's see here. There's an x to the 4th. There's no x cubes, x squareds. So there's a -8x squared and a -x squared. So that's minus 9x squared. There is a single x term, which will be a positive 4x. And then a 16 minus 4 looks like it will be a plus 12. So we're going to integrate the polynomial x to the 4th minus 9x squared plus 4x plus 12. So when we do that, it looks like we'll have our constant pi out front. We'll have 1/5 x to the fifth minus 3x cubed plus 2x squared plus 12x. And that'll be from -1 to 2. So we're going to need a little bit more room to write, so I'm going to slide down a little bit. Alright, so let's let x equal 2. So the pi's out front. Plugging 2 into this thing, we're going to have 32 fifths minus 8 times 3 minus 24 plus 8, and then plus 24 again. So without hesitation, I'm going to throw out the -24 and the +24. But I also got to subtract off when I let x equal -1, and that's going to be a place where I need to be careful. So I'll put the pi out front. So I'll have -32 fifths. That'll be a minus and a minus, so it'll be a plus 24. It'll be a plus 2. Wait a minute, no. Let's go back. I'm plugging in -1. I was plugging in -2, my fault. So let's clean that up a little bit. You're probably wondering what was wrong with me. Good thing I caught it now. So I'm going to plug in -1, so it'll be -1 fifth plus 3 plus 2 minus 12. So now we got quite a bit of things to collect. Unfortunately, let's see here. We'll have the pi. We'll have 32 fifths, and then we'll have plus 1 fifth, so that'll be 33 fifths. But then the numbers, we'll have 8, and then we will have -3 minus 2 plus 12. So that'll be 20 minus 5, so it looks like 15, if I'm not mistaken. Yeah. So I don't know if we want a common denominator there, but we've got pi times 33 fifths plus 15. So what is 15 times 5? So if we just keep going with this, this is 33 fifths plus 75 fifths plus 33. Hopefully I don't mess this up. So it looks like 108 fifths pi as an exact answer. And if I try that in the calculator to get an approximation, it looks like it's about 67.86. That seems interesting for the shape going around the x-axis, so it might be worth me investigating a little bit more, but we'll see. I'll let you know if anything's wrong.